Oh, that's cool.
Yeah.
Okay, so this week we're going to do two topics: threat intelligence and social engineering. So the exercises will be split. It'll be kind of like schizophrenic as a class. Um, but that's what we have in store for this week. I'm going to start with threat intelligence. So what is threat intelligence? It's about gathering real-time information about any adversarial groups or adversarial campaigns against your organization. And then it's also gathering very specific information that these groups are using to perhaps attack your organization. So like the machines, the networks, maybe the URLs, the phishing lures that they're using to try and compromise your employees. So that's what we refer to as threat intelligence. There's a real problem here is that there's a deluge of information on all of this stuff. And it's kind of impossible for a single analyst to keep track of all of it. So you need some kind of automation to be able to take all that information, all that data, create actionable information, and then to do something intelligent with that information. So you have the problem of the volume of information that is out there, the fact that when you want to do an investigation and figure out how all this data, what meaning comes out of all this data, it's usually very time consuming for the analyst to do that. And because it's changing all the time, like the infrastructure that the adversary using is very ephemeral. And then the techniques that they're using, they're doing just like us. They are lifelong learners and they're learning to adapt to defenders. And so all the time they're updating their techniques and their sort of attack vectors. And so the defender has to be able to keep track of all of this. And so you could see how automation with AI might help this problem. And that's what this week is about. And so this is where an announcement like this, which is just from a couple weeks ago, that Google's like, we have all the information, we have all the intelligence, and you see around the outside all the intelligence that Google has. In fact, they reacquired VirusTotal. They have all their cloud infrastructure that collecting all this data. They're like, well, we have all the data, but now we need to be able to add things like Gemini to this mix so that we can actually process all the information we're collecting to do something intelligent. And that's what this particular announcement is. Here's another one where this particular company is like, okay, we are trying to make the security operations center. So they're focusing on a very specific application. So at Portland State, we have a SOC, a security operations center that OIT runs. And some of our students have actually worked in the SOC. There's a whole bunch of manual work that they're doing. And so like, if you want to be more efficient in the SOC, you would do that. You would look around and see all the tasks that are requiring manual sort of effort, and you'll look to automate all of that stuff. So this particular company went down and listed all of the different things that these folks in the SOC are doing. So they're scanning all the machines for whenever new CVEs are released, they're scanning all the machines to see if any of their infrastructure has that particular vulnerability active. They're looking for a real-time feed of particular targeted systems or users. So say a particular user is getting attacked all the time, the SOC will probably try and inform that target that, yes, someone is going after you. And this is something that companies that are like, but there's like the very targeted person in every organization. And they're like, I have to signal you out for training because you're the juiciest target that we have. You'll see in a SOC, there's just too many alerts coming in from all of the sensors that you have placed in your machines. You have like thousands of these things going off every day, but you only have a handful of analysts. And so you have to be able to automatically prioritize the important stuff from the stuff that's not so important. And they also, they often say, all these companies are buying these endpoint detection pieces of software. And it's great that you can detect, but it's completely a waste if that's all you do. Like if you don't have the bandwidth to respond, then all you're doing is just saying you're in trouble. And then that's it. and then the signal gets lost. And then identifying your active attack groups and the procedures that they're using, because this can allow you to prioritize how you deploy your resources to defend. And so, like, if you're a financial institution, you'll be like, oh, I'm going to look at the fin groups, see what they're doing, and then I'll just prioritize fixing some of those threats that the fin groups are trying to or sort of vulnerabilities that the fin group is trying to leverage. Okay, so there are many types of intelligence you can collect. You can collect it at the IP or the network layer, so malicious machines. You can collect it at the DNS layer, so malicious domains, sites that host malicious software. You could do it at the URL level. So if someone is going to send you a phishing lure, they popped up a website and say and have trying to lure people into a fake login page, you could get information on whether or not a particular URL is malicious or not. You can get information about email domains that might be malicious or temporary, or email addresses that have been known to send spam. And then you could get information on the application vulnerabilities. What are the latest CVEs and how severe are they? What is their CVSS score? So whether or not I actually have to do something about this CVE would be a kind of intelligence that you might use. And then finally, you have the MITRE ATT&CK cyber threat intelligence information. And this is information about all the different threat groups that have been enumerated across the world and what they're doing to try and attack organizations. And so we have labs for all of these things, just to give you an idea of what you can do with automation and these information sources. We have a whole bunch of people and APIs and companies selling you all of this intelligence. This is where they're making money. They're collecting all this information, and hopefully it's useful information, and then they're upselling people who need it, and then that's their business model. And so I'm not gonna pay for any of these things, but I looked around for free versions. I mean, like Census and VirusTotal and all these other sort of enterprise level intelligence companies, they have like just terabytes of data and like thousands of APIs that they export to allow you to leverage that data. And so I looked for the free versions of everything just to give you an idea, just a simple idea. And VirusTotal actually allows you, it's a generous free tier. They give you access to all of their backend data, and they just limit the number of requests per month on the free tier. So I feel like that data source is probably the best one that you can use if you're going to do a project that uses VirusTotal APIs. Use that one, and yeah, it has like 300 calls a month, but you should be able to stay under that. Well, hopefully. If you have a runaway agent, though, I ran into this actually. I had a runaway agent, and then I think I got towards half of my consumption of my daily consumption. There's a daily quota, actually. It's not a monthly one. It's like 300 or 400 API requests per day. And so like I had a runaway agent that actually used half of that, and I was like, oh, I'll just have to wait till tomorrow if I run out. So that's one I recommend. So at the IP layer, there's IP info, IP who is. VirusTotal has intelligence at every layer, like URL, IP address, all of the different malware samples. It's got everything in their API. Certificate transparency, this only has information about registered TLS certificates. So that is specific to HTTPS. Right, DNS, sort of who is a DNS record check to figure out who owns a domain. Mail check is information about the email domain, the email behavior of a particular domain. Safe browsing is a URL safety data source. Fish tank is it's a URL, a phishing URL database. So if you have a URL that you're like, is this a lure or not? Fish tank, this is owned by Cisco now, and this provides you the ability to just take any URL and look up whether it's phishing. Email verification API, this allows you to identify email addresses that have sent spam before, or whether or not the email address is ephemeral, it's never been seen before, or temporary. It comes from a domain that issues temporary email addresses. So that's what this API is. Open CVE is where we're getting our CVEs and our sort of common weakness enumeration and vulnerability information. And then this MITRE ATT&CK taxi server, this is where we're going to get our information about threat groups. Okay, so many types, many sources, and then the labs are just a little bit of a tour through all of these things, just to give you a flavor for what's going on. So I'll start with the network layer one. So this is the first script. It's a network intelligence agent. And then I'm going to just show you two tools. And then you can figure out how you might want to add things to it if you want to extend it. So the first one is IP-Whois. And I have all of these agents structured the same way. I want you to figure out what this API takes and what it returns. And then you're going to write the tool description so that the agent knows how to call it and what to ask it for, and then how to process the results. And so that's this one is IP-Whois, and it turns out, I guess I give you a hint here, this gives you the location, geographic location of a particular IP address. And then I have another one, an IP report tool. And if you go to VirusTotal and you look at this API and you figure out what this returns, it returns you a report in JSON of what this endpoint provides you. And then you can go in there and look at the schema and you say, hey, if I have anything that can be answered in this object that comes back, I will write that in the tool description. So I can say, hey, this IP address is malicious, or this IP address is part of a Tor network. I don't know if it reports that. Some of them do. To say, hey, this is a known Tor proxy, or this is a known proxy server. And then you'd be able to, in your comments or in your tool description, you could say, okay, if you need to figure out if an IP address is a Tor proxy, you just like put it in there. And then hopefully the agent's smart enough, the agent reads your description and says, and then when you ask it that question, it knows to ask this tool rather than something else. Okay, your mileage does vary on this thing, especially with Gemini. So hopefully this works. And I only give you, I give you 2 or 3 tools per agent because of the limitations of, I think, the LLM right now. But eventually you'd be able to do this more reliably. Okay, so then the next set of information is DNS intelligence. And so for certificate transparency, the crt.sh, this gives you all of the TLS certificates for a particular domain. Anytime you register an HTTPS domain and get a TLS certificate, you must publish that to the certificate transparency server. And then this server keeps track of everybody's registration. So when Google renews its certificates, it shows up here in crt.sh. And so that's a rich form of intelligence. And so this is just pulling it. This is just scraping the website and saying, hey, I'm going to scrape this URL and then ask you to output JSON. And then I just return the thing in JSON. I have been finding that when you return data back in JSON, it makes the LLM happier. I just get more reliable results for whatever reason. I actually don't know the reason. I've just been mucking with it. And like raw text sometimes, it just can't figure it out. So go figure. Okay, so then same thing as the IP address ones. You're going to change the DNS, the tool description for the DNS tools to describe everything that can come back from this particular access. And you can go see the JSON and see the fields that are returned. And then email domain search. So this is the mail check API, and I'm going to have you access this via Rapid APIs. So if you haven't used Rapid APIs before, it's an aggregator for a whole bunch of really cool APIs. There's like hundreds of APIs, and it allows you to get access to them using one API key. And that's why I'm like, okay, well, so I looked, and they have a large page of sort of open intelligence APIs. And I picked some that were free. And so you have to go, when you create your Rapid API account, you have to go to the service that you want to use and you have to subscribe to it. And then for all the services I have you subscribe to, there's a free plan. So some of the Rapid API stuff, you require a payment through a Rapid API, but I found the ones that are free. So you go and you subscribe to the API and then use the free plan, and then you'll be able to get this to run. And so this particular tool is just going to tell you whether or not it's been used for spam or whether or not it's an ephemeral domain. so that you can figure out whether you can trust this thing. And then you would just fill that in. What is the data that gets returned? And then I'll change the tool description to match that. And then the last one is a simple whois domain search. So if you want information about the company who registered the domain, then this just spawns a shell command, the whois command from the command line. And it says, I'm just going to run this in a subprocess where I'm going to just take the domain that's given as an argument and then just run whois on it. And then you just change the description based on what the tool returns. Okay, so here's another one, URL intelligence. So this is the way you access the safe browsing API, and this is a Google thing. And so in order to enable this on your account, I'm going to have you use your same Google API key that you're using for Gemini, but you have to go into your account and enable access to the safe browsing API. We actually enabled the generative AI service on that API key earlier at the beginning of the class. You'll just add safe browsing, and then you can reuse the exact same API key. So that made it. That's why I was like, you know what? I'll just throw this in there anyway because it's easy to set up, and that's what this one does. And then it tells you give it an API, you give it a URL in the safe browsing thing, and then you give it the threat types that you're interested in labeling the URL. Like you want to know if the URL that you give safe browsing falls under any of these categories. And what the safe browsing API does is it gets all these URLs and labels them. And then you're just basically retrieving the labeling from Google. And then you basically access the API using your Google API key, and then you return whatever the response is. And so again, you're going to figure out what's in the response, and then you're going to change the tool description to indicate what that is. Okay, VirusTotal does something similar. So you give VirusTotal a URL, and then what happens? So VirusTotal does a real in-depth scan of the URL, and if the URL is pointing to content, it'll download that content and it'll do some like analysis of that content and give you some really a deeper look at the information that URL is pointing to. And so in order to get access to this, first you have to provide this endpoint the URL that you're interested in. And so you attach your VirusTotal key, and then you post onto this API endpoint the URL you're interested in. And what it does is it returns the record for that URL that might list a previous scan that it has done. So this is not a real-time API because it takes work to actually take a URL, and if it has malware in it, to actually do the reverse engineering. And so for a URL, if someone has done a scan previously on that URL, then it will return the ID of the last scan. And that's what this thing is doing. It's trying to find the ID of the last scan in the links, and then it's going to access that report. If you access a URL that doesn't have a report, then this thing will break. This won't return anything because, well, what it'll do is it'll kick off a scan, and then it'll return you a scan ID that you can fetch later to get the actual information. But I'm like, when you do this lab, just use it on domains that are common or URLs that are commonly accessed, and then you'll be okay. Okay, so that's VirusTotal. And then the last one is for the URLs is fish tank. So for fish tank, if you have a URL, maybe you could pull this out of phishing email. So you go into your spam and you're like, oh, here's one that's trying to get me to visit this link to go log in and get my credentials. I'll copy and paste that into this API endpoint. And then fish tank likes you to specify who you are in your user agent. So that's why this is set this way. And then you just paste that URL, you post that URL to this endpoint, and then it tells you whether or not it's in the fish tank database. And if it's in the fish tank database, it's a phishing link. And it's a simple binary decision. So I already gave you the answer to this, but you can actually take a look at what this API returns, and you can see there's some other things that it returns, but basically the way this tool is written, it only cares about the one attribute. And so you can almost write this one already. Okay. The next thing is email intelligence. So there is, again, this is through Rapid API. This OOP spam filter is basically a hosted spam content detector. And so all you have to do is give it some email content, and then you post that content to the API endpoint, which is here. And then it returns you a report on that content. How many spammy words are there? What is its rating between 0 and I think it's 6? You have to figure out, like, it'll give you a score. And then the tool description is going to have to talk about, well, how do I translate that back into whether or not this thing is malicious or not? And that's this exercise. The next one is if I get an email address from the user, how can I get information as to whether or not it's a spammer email address, if it's ephemeral, if it's part of a webmail service? And so this is where this API, free API, will get you all that information. And then you would update this comment to indicate everything that this API can return. Okay. The next one is application intelligence. So in this particular one, we're only accessing OpenCVE for both of these things. So we have the CVEs, which are the actual vulnerabilities that are being reported, and then the common weakness enumeration. This is a more static enumeration of all the different oopses that the software developer has made in terms of programming software. All the common sort of defects that developers put in their code, they enumerate those so that we have a naming system to talk about them. So for example, you can look up SQL injection and it's got a CWE number for that particular vulnerability. And so in this case, you have a tool. And then one of the things with CVEs and CWEs, they have a very specific syntax. You have to make sure it matches that syntax or this query is going to fail. So if you look at this tool, you'll see that most of the other tools, I didn't bother with the Pydantic class. I was like, whatever. I'm like, this is just, it's too verbose to like put it on everything. This particular tool actually kind of needs it. I think it needs it. And so you're defining a tool and you're saying, I'm going to hit this CVE endpoint with the CVE ID. And then I'm going to use for OpenCVE, it's not an API key that you use to access this. It's basically a username password. I don't know why they did it this way. It's probably because they don't have enough developers to actually build an API key system. I would guess, I mean, it's an open project, so I'm guessing they just don't have enough developers to do this. And so you can see the information that it returns, and it'll return it in JSON. And then this is the thing that actually enforces a particular regular expression match in order to ensure that this is a valid CVE ID that gets passed in by the LLM into this tool. And you can see the CVE number is capital CVE dash, and then 4 digits, followed by 4 or more digits, because it turns out there are so many CVEs that you can get into the 10,000s now with CVE numbers. But the first 4 digits is the year. And so, yeah, that'll be 4 digits for all of our lifetime. So we're fine. That'll be there. And I don't expect anybody to be running this code when it gets to year 10,000. Anyway, and then I'm just going to have you say, just change me, like, describe what is returned so that the LLM is able to know to invoke this tool for particular information. Okay, here's another one, the CWE, common weakness enumeration. And again, this is very similar. The CWE is starts with CWE, and then the digits are between 1 and 4. I think there's basically 1,100 CWEs. There's only so many classes of mistakes we can make as programmers. I can't believe there's 1,000 of them. Because inevitably, when you write a piece of code, I bet you something in the code you write is in that 1,000. But it would be interesting to check. Actually, it'd be interesting to do a RAG where you're like, here's some code, go through all the CWEs and see if any of these CWEs are in the code that I give you, and then return the CWE numbers to me. That would be cool for like software auditing. I mean, we did the vulnerabilities and the code summarization tool thing. You could do something like that, do a RAG with CWEs. That would be a cool project. There is a RAG with CVEs, actually. There was a paper from Illinois where they took the CVE and they took a website that had it. they asked the LLM to compromise the website given the CVE that the website was vulnerable to. And that was where GPT-4 could compromise the site 80%. Is it 75 to 80%? Do you remember that number? It was a crazy high number. And that's, yeah, it was like 75, I think, or none of the other models got above 7 out of 9. None of the other models got above like single digits, but then GPT-4 was able to do that. And that's a RAG. They're taking the CVE description, so it's a RAG, and then they're attacking a site with it. So that's a RAG with a tool. And that was an interest. If you're interested in that paper, I think it's in the slides somewhere. I think I might have mentioned it. You could basically start with that using this kind of tool. Okay. All right, the next one is the threat group intelligence. So this is trying to figure out groups that have it in for you and figure out what they're trying to do as a sort of an operation, a global operation. So one of the best articles, and this sort of inspired the exercises. So the exercises that you're going to do with regard to this, I pulled it out of pointers that I got from this particular article. And so one of the things that you would want to do is to build a RAG where you're able to download all the techniques that threat groups are using in real time. And that's what this RAG is doing. This comes from Roberto Rodriguez's Gen AI Security Adventures. Both of these two tools that I'm about to talk about came from this repository. And the first one is a RAG. So this is the idea. You want to figure out the techniques that a particular adversary is going to use against you. So Lazarus is one of these. This is a North Korean operation. So if you know that you're being targeted by North Korea to get all your money, North Korea targets everybody because they're just trying to get money out of you. Like some organizations, they're targeting very specific things, but North Korea, because they're trying to get money out of you, everyone's a target. And then if you feel like you're being targeted by Lazarus, you might want to look up, well, what exactly do I have to protect against? And so in this case, if you give an LLM something that's this, it's like, hey, go find out what Lazarus is doing and give me a markdown with, the data formatted in a particular way, then you could generate something that looks like this on the right. Okay, here's another example. I think this is from Claude. They're like, hey, give me a technical report on this ransomware group and give me everything that they're doing. And then this is, give me the MITRE mapping for it. And then it produces this thing on the right. Well, on the bottom, actually, because they get the summary and in the columns. So we are going to run one of these things. And so for the RAG application, it's split up into multiple small Python scripts, just like your RAG, if you remember, like the second week of class, where we did the RAG, where it was step by step. We're going to do the same thing, but we're going to use the MITRE attack data instead of like PDFs and CSVs and those sorts of things. So this is what you're going to be running. There is a Python package, attack CTI, where you instantiate this attack client, and it can go off and download all the information, the MITRE attack information in real time from a MITRE attack taxi server. So there's a protocol called taxi, where it's a way of transferring all of this information from a server to a client. So you're going to instantiate an attack client, and it's going to give you all of the techniques used by all of the groups that it has in its database. And that's basically this API call. Get all the techniques used by all the groups, and it gives you just a huge amount of techniques. And then what happens is you're like, oh, I want to figure out all the groups that exist, and then I want to take all the techniques, and then if a group is using one of those techniques, I just want to attach it to that group's sort of playbook. So you're basically generating playbooks, per group playbooks, with the techniques that you download. So you download all the techniques have all the groups that are using that particular technique, and you're producing the index of groups with the techniques they use instead. And so that's what this thing is doing, downloading all the techniques. And then if a particular group uses a particular technique, you append it to that group's entry. So that's what this particular piece of code is doing, along with all the other information about the technique. And then what you're doing is, so now that's all in a big old dictionary in Python. You're going to create documents that have all of this information about this particular group, and you're going to store it into the file system. So in this case, in your directory, in your MITRE RAG data directory, you create a documents directory. And then what you do is you go through all of the groups and you basically fill in a template, a group template, based on the information you have in that dictionary. So you're going to create markdown files for each one of these individual groups. You're going to read the markdown template, and then you're going to go through all of the groups and generate a markdown file for that group into this directory, documents directory, using the group's name. And you're going to take this markdown template and render it based on the data that's in this group structure that you generated at the beginning. So what this looks like, this is a long-winded script that gives you, this is what that directory looks like. It's like all the threat groups for that particular taxi server. And these are all basically up-to-date threat groups with the up-to-date techniques that they're using in your directory now because you downloaded it. And I would say each one of these markdown files is maybe like 2 kilobytes to 32 kilobytes based on how prolific the threat group is. And then this is what one of those markdown files looks like. So this threat group, I chose this threat group not because of the name, but because it was a small file that I could fit in the slide. But this is suckfly. And then it basically, this is the markdown file that got generated by your Python script, right? And it's got all this information. And of course, this, I don't know if you're good at parsing markdown, I'm not, but this renders to this markdown. And so you get the format that the previous screenshots were giving you. And this is done automatically. So that has nothing to do with an LLM. That's just the data as it's being prepared. The LLM comes is we're going to take this data and we're going to load it into a vector database, right? And so we've done this before in the RAG application. We're going to say, hey, I'm going to go with this unstructured markdown loader. This is my document directory. These are the files. And I want you to load all of these files using the markdown loader. And then I'm going to create these documents that have the loaded sort of markdown files in it. And I'm going to add it to this group, this list of documents, and I call it markdown documents. And I'm going to, in one step, I am going to both load and then do the chunking. So you can use load and split. And then it just uses the default text splitter as you're doing the load, and then generates the split documents automatically. And I did this for conciseness, right? I didn't want to have to define a recursive character text splitter and show you that code. So I'm like, okay, I'll just use the default. And it actually still works. It works well. So it's like, okay, I'm not going to actually show you the splitter. So it's doing it all in one. And then I'm just going to use the embeddings, the Google Generative AI embedding. And I'm just saying, let me create a vector database from these documents with that embedding function. And then stick it in the ChromaDB directory, just like we did in week 2. And then you can do a similarity search. So tell me about APT28. And then if you run this, you'll get all of the different chunks from the APT28 markdown file. And the APT28 markdown file is pretty big, so you'll get multiple chunks. Whereas like the previous suckfly one, that was one chunk. And then you'll see other groups that are when you run this part, you'll see other groups for that particular threat group. Okay, then the last piece is to do a RAG query. So then you could just say, tell me about APT28. And then I'm using a special chain that I haven't used before. There's this load question and answer chain that this particular implementation used. So I just borrowed whatever the script, the original script writer used. And so this is a stuffing chain where you basically stuff the documents into this chain along with the prompt and the LLM, and then it just generates when you invoke this particular chain. Oh, so the other part of this is you have to pull out the relevant documents from the vector stores retriever object. So that's, do I define the retriever? That's not here, actually. I should have put that in there. Yeah, so the retriever is from the vector store. And so you get the relevant documents based on the user's query, and then you invoke the chain with the input documents that are returned from the vector search, and then you attach this query, and then this chain will run and then output the result. And that's what you'll see with this particular RAG query. Okay, the last threat intelligence agent is this Mystic Pi agent. So Mystic is Microsoft's threat intelligence community, and they have a package called Mystic Pi that is a really sort of powerful Python package for you to access a variety of threat intelligence sources. This is kind of the LangChain for threat intelligence, right? LangChain allows you to use all the different models from all the different vendors. Mystic Pi allows you to use all the different threat providers that are out there, assuming that you have accounts set up for each of them. And so we have an account set up for VirusTotal. So we're going to use Mystic Pi as an access way to use the VirusTotal. I already showed you how to use VirusTotal directly, but Mystic Pi gives you access to a whole bunch of other things. So I'm going to show you an example here of using VirusTotal through Mystic Pi just for fun. So here, so these are some of the threat intelligence sources that you'll see. These are the common ones that you'll see. And then, so the Mystic Pi agent that's in the repository is a stripped down version of what the generative AI adventure, security adventures agent had. And it's just a simple agent that ties together two API calls in Mystic Pi. And that's it. And there are dozens to choose from. Like when you go and look I have you go and look at the documentation for Mystic Pi, and you can see there's way more stuff that you could get access to if you're interested in doing that for a project. That's fine. But I'm going to show you two. And there's these two simple ones. The first one is, this is native to the threat intelligence on Mystic Pi. This is threat intelligence lookup. And it's basically a method, an API call that says lookup indicators of compromise is what an IOC is. And so this is the code for it. So from the Mystic Pi security tools, I'm going to do a threat intelligence lookup. And I'm going to say, do a threat intelligence lookup. And I'm going to give you, so this method can be queried based on an IP address, or you could give it other kind of observable information. So it depends on, so every indicator of compromise has a whole bunch of attributes that are associated with it. One of them is the IP address that it was observed on. And so lookup IOC allows you to specify any of those attributes to look up an indicator of compromise, and we're just going to use the IP address as just one of them. So I just say, hey, this is a particular IP address that I want to look up. The type of this observable is an IPv4 address. And then I want you to query VirusTotal to say, hey, is there anything at this address that's interesting? And there will be a whole bunch of stuff that gets returned, but this particular tool doesn't want all of it. It just wants the files that this particular IPv4 address has been seen to communicate with. So if it has sent something, then in this is a pandas data frame that comes back here. And then this particular function is going to go and look at the detected communicating samples in this data frame. There's a whole bunch of other stuff in there, but I'm only going to take one piece of information. And then it returns the communicating samples that come back. So that's basically, and it returns it as a JSON object from this pandas data frame. So you're going to look at this, and you're going to look at that data structure, and then we'll develop a tool description. The tool description is later on, because this tool is architected slightly differently than the other ones. The next thing I'm going to have you do, and this is a very specific VirusTotal lookup call. So VirusTotal has multiple API versions. So this is a VT lookup on version 3 of the API. And this is how you access the native VirusTotal lookup API. So I'm going to create the lookup object from the package, and I'm going to invoke this get object call. And what get object does is it takes an ID, and in this case, it's going to be a file hash. So in the previous tool, what gets returned, one of the things that gets returned from this JSON object is a file hash of any of the files that the communicating samples have come. So you're not going to actually store the file. when you do this kind of threat intelligence, you're going to store a hash. And then the file itself gets stored somewhere else, like indirectly. So you'll get the hash as part of this JSON object. And then you have this other tool that takes a hash and then we'll go query for all the information about that hash. So somebody has done an analysis in order to generate this hash. And then this particular API is like, given a hash, I'm going to give you the analysis that was done previously on that hash. And that's what this is. I'm going to look up that object given its hash and say, this is a file object. And I want this is a file hash that I'm giving you. And then I'm going to return the analysis of it. And then you can go and you look at what gets returned as part of this analysis object is the result here. So then what I have you do, this is the way the tools are defined, and then the descriptions are actually included as part of the tool constructor. And so what I'll have you do is fill that in for this particular one. And it just be something simple, really simple, because this is just we already know what we're like, you can tune it to the questions that you're gonna ask, and then you'll be done. Okay, questions about the threat intelligence stuff that you'll be doing today? So hopefully that'll make sense when we walk through the labs. The next part of your labs is the social engineering one. This could have actually used an entire week, but we don't have enough labs right now written for it to deserve an entire week. So we're just going to put both of them in this week. But this is kind of more the fun thing, I think, to do because it has more of a human element. So one of the problems with generative AI is that it's being used for social engineering, especially for adversaries who aren't good at crafting English or communicating well. They're like, well, generative AI is a boon because I can just say, fix my English and then send it off. And this is basically how financial scammers are getting very good at what they do, and how you can get these really convincing website lures that trick users. So unfortunately, there are specialized tools for doing all of this now. So Fraud GPT is one of them, and it does all of this stuff that you're like, oh man, I wish it didn't do that, but it does. And these are things it's going to be hard to control the malicious use of these things. And then this is another one, Worm GPT. And there's a list of all these malicious GPTs that are out there. This particular one focuses on phishing, business email compromise, which is really a lucrative segment. So we're going to just walk through the use of these tools for these malicious purposes. And some of these things you'd have to jailbreak the LLM to actually get it to do anything. But that's easy enough to do. We've already talked about how jailbreaking works. So here's an example. This comes out of Fraud GPT. It's like, hey, give me a site that looks exactly like Bank of America. And then it will produce that code for you. Here's another one that it's being used for: generate fake profiles on social media. So dating sites, professional sites like LinkedIn, these are things that it's just showing up everywhere. So I'm particularly sensitive to the LinkedIn ones because I have LinkedIn and I get like hundreds of these things. And you're like, I don't know this person. This person has 2 connections. It's got a really, wow, this person is super experienced, looks 25, but has gotten an education that's like a 30-year-old or a 40-year-old. And I'm like, oh, wow, probably phishing. And so this is definitely this came from this article. You'll see this. If you're on LinkedIn long enough, you'll see a lot of this stuff going through. And so your lab exercise is to generate a fake profile. See if you can get something that looks like this via prompting, and just see how good is it. It's probably going to be really good at doing this. The next exercise is just simple phishing. So phishing can be done using multiple modes. And so this is basically creating a believable lure given a specific context. So you have to, in order to make phishing work, you actually have to contextualize your message. You have to contextualize it in the context of a conversation or based on a relationship that you already know pre-exists. And that's what these lures are about. So in this one, I think this is Worm GPT. Write a convincing email that comes from the business's CEO, and then it basically gives you this particular text, and then you would just fill this in. Um, Here's another one. You're like, hey, I want to target it to the mode of communication. So SMS text messages are one of these things. So if you signed up for SMS alerts on any of your financial institutions, all of the formats of those text messages are well known. And so Worm GPT is like, I'm going to give you the exact format of a text message that people are going to get so that they can be lured to click on this short link based on that. So that's no, actually, so this is actually Fraud GPT as well. Okay, so your lab exercise is to generate these lures with these particular contexts. So company president informing employees of a year-end bonus and clicking on a link to like a Google form to register their banking information so that it can be wired to them directly. Notification from a vendor, a bank, a payment provider, a solicitation from a job recruiter. You get this a lot with LinkedIn. You get solicited, and it's like, hey, you're looking for a job. I have a job. I'm a recruiter. I have a company that is looking to hire someone with just your skills. And then they go off and they pull all your financial information and do your background check do a background check and then wipe you out. Okay. The next exercise is misinformation, and disinformation. So this is basically false or misleading information. It could be intentional or it could be just kind of a sort of accidental, I guess. And then this is being used by a lot of people, and we're in election season now. There's an election year. This is going to be big. In fact, the Vanguard asked me to comment on AI for political malicious AI use for political campaigns. That's how much on the radar this stuff is. Because if you can fabricate a whole bunch of stuff and convince people to either not vote or to vote a certain way, you've shifted an election. So this is one of those years for that. And it turns out this is a cool paper. It's like, yeah, LLMs are better at producing fake news than actual people, and that's really a problem. Now the question is can we write the detector that's also as good? And it turns out, I think you had found a detecting thing that was part of this paper, or that was just a generator that you had come across, but is a separate thing. Okay. And so here are just some examples of basically all of this untruthful, malicious content, misinformation that's being just flooding the internet. And so this one, I think, was an April Fool's joke, but this is one of the most infamous ones where it got at least some people. Okay, so your lab exercise is to try and get an LLM to generate misinformation. And so the examples that you're going to use to try this is from this study, LLMs meet misinformation. And some of the prompts that you're going to use come from this paper. And then the subject of your misinformation could be any one of these topics. You know, if you're trying to do an opposite position to what the truth is, then you would see if you can craft some kind of persuasive article that does the opposite of generating the truth. Okay, so the last exercise is pig butchering. So if you've never heard of pig butchering, this is a huge number, $75 billion. And the way they got 75 billion, this is not some funny estimate. This is actually looking at cryptocurrency accounts for people suspected of doing this thing, of pulling in these payments. And so they analyzed the blockchain and they found all of this aggregation of cryptocurrencies from things that looked like payments that were from people who were tricked into doing this. So what this is that, I don't know if you get text message spam where they're messaging you. What they're doing is they're trying to start with a wrong number text message. And then when you respond, then they're going to try and set up a relationship, communication relationship. And what will happen is that they want to build trust in a way that they can convince you to send them money or to invest in some new product like an investment vehicle. And that typically is going to require you to purchase cryptocurrency and to send it somewhere. And then once they've sent that once the victim has sent the cryptocurrency, then the pig butcher disappears. And so this is a huge problem. And basically, they're using ChatGPT now to do some of this stuff, to have a believable persona on the other end, try and convince people to send money. And so we were like, well, we don't actually want to have you write malicious software. So David and I were thinking, well, let's just have a agent do the opposite, pretend to be a juicy victim just to keep the pig butcher at bay, to keep them from compromising some other victim. So we're going to take away their resources. And a chatbot is perfect for this, right? Like if you can configure a chatbot to keep a pig butcher in the lure long enough, then that's time that they don't have to spend on someone else. So that's the idea. So there's a conversational agent in your repository pretending to be a victim, and then you can configure the persona and the instructions that this agent will take on in response to pig butchering. And then the idea for you is to be the pig butcher to test out the agent and then to see how can I improve this agent so that it actually is more like it can keep the person lured in longer. And so I thought that this is probably going to be a fun one to do. And I wish you should all try it, even though only one group is going to present on this particular one. Okay, so with that, that's all I'm going to talk about content-wise. I'm going to take a 5-minute break. But in the meantime, in that 5 minutes, I want all of you, to go to your billing account to check on your GCP credit. If you are below $10 already, send a screenshot to me so I can issue you your coupon. I want to get your coupons issued now before you run out while you're trying to do your final project and then waiting on me to issue you one. So I'll get this out of the way ahead of time and just Slack it to me, and then I'll send it to you after class.